Okay, sampling. Okay, and then quantize, quantize and encoding. We got the three different process. Okay, so how does signal look like? Okay, before this is the original signal, because the function of the PCM is from analog ADC, analog to digital converter. Okay, the function of PCM convert analog signal to digital. Okay, so sampling, you must follow the Nyquist rate. Okay, sampling, what is the process? Something like you chop the analog signal. Okay, how to get how we want to know where we want to apply? You must remember this formula. Sampling must bigger or equal than 2 FM information signal. Info signal. Okay. How about the quantize? Quantize, something like you want to assign the level. You must know 2 power of n. Okay. Let's say n equals to bit. How many bit you use? Okay. Now, after that, encoding. Encoding what? Serial bit stream. 0101. Okay. So, after encoding, normally, encoding, we will go through line coding. Line coding. Okay. Line coding, for example, Manchester. Okay. Manchester and so on. Okay. Now, let's look on this question. Okay, directly. So want to something like to make sure we fast learn. Okay. Normally, in this question, we give you analog signal. Okay, analog signal. Okay. So this analog signal, this is the analog signal. Okay. We need to transfer it so that it become 010101 output. Okay, so how to solve this thing? Okay, remember, settling something, please examine the amplitude, maximum and minimum. Okay, check the amplitude. Here is the amplitude. Another is time, microsecond. Okay, make sure you know every detail. Okay, so let's start how to analyze this thing. Okay, so the first question, okay, PCM is the method used to digitally represent sample analog signal. Okay, and then see the first information, what you see. Okay, so from this question, can see something like the highest amplitude is 6 millivolt. Okay, 6 millivolt, the higher 6 millivolt, and then the lowest amplitude is negative 6 millivolt. This is the first info you must know. Okay, then what happened? The input signal is encoded using 3-bit system. Extract this thing, 3-bit. This means this one will use on quantized part. And then with the 250 kilohertz of information signal, you must know this is not FS, not the sampling frequency. This is the information signal. Okay, so you must multiply by 2. Okay, so your sampling frequency is 250 kilohertz times 2. You got 500 kilohertz. Okay. Okay. Now, in this question, requires you construct the quantization table. Means for quantize. Okay, what is the function of the quantize? Okay, quantize. Actually, at this quantize, we want to assign level for analog signal. Okay, we want to something like assign. What, for example, 5 volt. What is the something? For example, from this signal. For example, this level. What is the voltage? Okay, second level, what is the voltage? Okay, because we want to convert from analog to digital. Okay, now remember one time, this is something like, okay, construct the quantization table. We want assign voltage level. Okay, voltage level. Okay, so you need to know about the quantized value, voltage range and binary code for each level. You must build the table. Okay, this is what we call on the quantization part. Okay, question number 1. Question number 2 is a input signal is sampled at time 2 microsecond, 4 microsecond, 6 microsecond and 8 microsecond. Actually, sometimes we don't give you this info. Sometimes we don't give. Sometimes we don't give. Okay, we don't give. Okay, sometimes. Okay, so how to solve? if this information not given, you take 200, okay, FM equals to 250 kilohertz, then Fs 2 times 250 kilo, you got 500. Okay, 500 K. Okay, you must find time sampling. Time sampling equals to 1 over Fs equals to 1 divided by 500 kilohertz. So 1 divided by 500 K, you got 2 microsecond. Okay, 2 microsecond Ts. Okay, in this question we already given. Okay, 2 microsecond, 4 microsecond, 6 microsecond, and 8 microsecond. If not given, you must sample, means you must chop this signal every two. For example, here 2 microsecond. Okay, if not given, okay, this one we given, right? The input signal as T1 2 microsecond, T2 till T4. If not given, you must sample everything every 2 microsecond interval. Clear or not? Okay, you must, if question not given. Okay, if not given, you must find interval every 2 microsecond. If not, you just follow here. Sample at T1, T2, T3, T4. Chop means this is at the sampling. Okay, question number 2 on the sampling part. Okay, sampling. Question number 1 is on the quantize. Okay, and then the last one, okay, the last one is the encoded binary PCM, means after encoding process. This one on encoding. After encoding, you put into Manchester. Manchester is underline coding. Okay. Okay. So let's solve this problem. Okay. Now, very easy. The first one, okay, you must know how many bits. Okay, how many bits? Okay. Right now we are using 3 bit. Okay, question number 1. So how many level you will use? L equals to 2 power of n equals to 2 power of 3 equals to 8. So you must know 8 level. Okay, how about the delta V? Okay, quantization interval. Okay, M max minus M min. Okay, sometimes we call V max minus V min. Okay, up to you. You can use both formula. Okay, how to get M max and M min? Okay, refer back to the analog signal. Okay, M max, you must see for this signal, which one is the maximum positive peak. Okay, so you got here 6. This one in this axis is millivolt, right? So you got the maximum one. This is the M max. How about the M min? M min, you got here. M min is negative 6 millivolt. M max and M min. Okay. So after you got that thing, okay, you take from here 6 minus 6, divide by 8, you got 1.5 millivolt. Okay, solve one thing. But when you want to sign, okay, right now this table normally we don't give. Okay, for example here, this thing, this table do by student. Actually we don't give you. Okay, you must know what is the, for example, you must know, okay, every after I got 2 power of n equals to 3 bit. So how many logical bit I got? Okay, remember something. Okay, how many table truths? Truth table. Remember, this is something that last time you learned in digital truth table. Okay, remember, assign level very simple. You know, 2 power of n. Okay, equals to 2 power of n means 2 power of 3. 2 times 2 times 2. Okay, 3 bit n equals to 3 bit. Okay, equals to 8 level. Okay, 8 level. Remember, in digital, we start from 0. That's why you see, actually, if you normal assign, it's 1, 2, 3, 4, 5, 6, 7, 8. This one is the normal, but this one start with binary. Binary start from, if digital start from 0 to 7. Okay, this is the first thing you must know. Okay, after that, you got this value from 0 to 7 because 2 power of 3 equals to 8 level. Okay, if 2 power of 2, you got 4 level. If 2 power of 2, you just stop at 0, 1, 2, something like you start from 0 to 0, 0, 0, 1, 1, 0, 1, 1. This one for 2 level. Okay. 4 level, sorry, 4 level. For 8 level, you must start from 0 to 7. So for 7, how many bit? Okay, 0, 0, 0 equals to 0, 0, 0. How? 2 power of 0, 2 power of 1, 2 power of 2. Okay, means 0, 0, 0. Means you add up, you got 0. How about level 1? 0, 0, 1 means this one 2 power of 0. 2 power of 0 equals to 1. 0 remains 0. Here means 2 power of 1. Here is 2 power of 1 means equals to 2. Here 2 power of 0, 2 power of 1. So you got 3. Same value. Okay. If you don't understand, convert this one decimal. Decimal you convert to binary. Okay. Binary. Okay. So 0, 0 equals to 0, 0, 0 till 7, 7, 7. 7, 7 means 2 power of 0, 2 power of 1, 2 power of 2. So 2 power, no, 2, 0, this one 0, 1, 2. 2 means 2 power of 2, 4 plus 2 plus 1 equals to 7. Okay. Okay, now once you set up this thing, first you set up the label and binary code. Now we start with the quantized value. Okay, quantized value. So how to start? That's why you must know another formula. V out, not V out, V means V initial. This is initial. Initial. Where's the location? The lowest part here, bottom part here. Okay, V not okay, the bottom part. Okay, clear? Negative 5.25. You must use the formula. Okay, so this one V naught, right? This one V naught. So how about V1? V1, V2, V3, V4, V5, V6, V7, sir. Okay, now so telling something. Okay, how you got V1? V1 is okay. Now you take this value, negative 5.25 plus, okay, remember, this is what is delta V. Delta V is something like different 20s interval. This is delta V, the location of interval. Every interval you got delta V. So delta V is 5.25. Dengar tak apa saya cakap? Boleh dengar tak saya cakap? Ke lost connection?
Tadi tak dengar.
Dengar tak?
Dengar.
Itulah sebagai tahu connection sangat teruk. Sebagai tahu something semua sekarang ni, sebagai tahu whole country right now line tak okey. So dekat ni sepunya Unify semua okey. No problem. Tapi bila kat sini saya tak tahu tiba-tiba hilang. Okey. Now dengar tak? Nampak tak screen sir?
Dekat table tadi ya, sir.
Nampak Okay, now we proceed. Okay, now after you need, okay, how to set up the first one? Okay, V naught. This one V naught. V naught means negative 5.25 plus delta V. Delta V means the difference of the voltage every interval. So to get the next level, negative 5.25 plus delta V means negative 5.25. This one milli. milli. So that's why I said just put 5.25 because all of the value represent in milli. Okay, plus 1.5 milli. So you got 3.7 negative 0.3.75. Okay, so the next one same. Okay, so the next value, how to obtain the value? So you got here 3.75. How about the next value? V2 negative 0.375 plus delta V. So every interval you just add up. So negative 0.375 plus delta V 1.5, you got 2.25. Clear or not? Clear? How to set up this value? Okay? Clear or not?
Clear, sir. Clear.
Okay? This one come in your final exam test. Don't worry. Confirm. Confirm. So if you don't understand right now, turn on your microphone. So will tell you very simple thing. Okay, you understand. Okay. Okay. Now, so clear. So every interval here you just plus delta V plus delta V plus delta V plus delta V plus delta V. Okay, clear? Okay, understand or not how to set up? Okay, delta V. Okay, now the next part. So want to show you after you already know how to set up this thing, you must know how to get the voltage range. Voltage range. Okay, how you got -6 to -4.5. Okay, okay, -6 to -4.5. Okay, so show you one tips so that you will understand how the table works. Okay, how the table works. Okay, okay, for voltage range. Okay, so give you one tips, you must remember, take note. Okay, so tell you something. Okay, -6 to 6. Okay, you must see actually this was represent your analog signal. Okay, your -6 here to 6 must be same. Okay, this is how you can double check whether your value correct or not. Okay, so remember I told you again, voltage range you must know -6 to -4.5. Okay, why we need to set up this voltage? Why we need to set up the voltage range? Okay, I told you, I tell you after this. Okay, now how to set up this thing? Okay, very easy. Okay, you take minus, you take this one. How to set up this value? Negative 5.25 plus delta V over 2. Why? Because we got two value. Here, for example, quantized value, you only got one level. Here, you got two value. That's why how to, after this, you will know why we assign 6 to -4.5, -4.5 to -3. Why? Because this voltage range will use to tally with your analog signal. Okay, the problem will happen after this. Okay, so the best thing you set up this thing first. Okay, delta V over 2. What is the value of delta V over 2? Okay, delta V over 2 is is 0.75. Okay, this one delta V over 2 over equals to 0.75. So negative 5.5. Okay, take the two value, negative 5.25. Okay, plus for example 0.75 and also negative 5.25 minus 0.75. Okay, you got two value. So you got negative 4.5 and also negative 6. The rest also same. For this part, you take negative 0.75, okay, uh, plus 0.75. Here, negative 3.75 minus 0.75. You cut this range. Okay, you continue till n. Okay, okay, clear or not? Okay, so give you 2 minutes, 1 minute to see how to set up V0 and so on. Okay, 1 minute.
Sir,
Yes?
boleh ulang balik yang negatif 45 to negatif 3 tu.
Okay, tak ada apa. Okay, saya bagi tahu something. Okay, negatif 3.75 ambil nilai sebelah ni. The quantized value negatif 0.75 campur delta V over 2. Ini sebenarnya delta V over 2. Yang sini pula, sini negatif 2.25 minus 0.75 plus 0.75 dapat negatif 3. Betul tak? Okey, satu lagi negatif 3.75 minus 0.75. You dapat negatif 4.5. Betul tak? Okay, understand? Kena ambil take note. Take note sikit, the rest you can build up. Remember, this table never give to student. You must build. First, step dia give you the step. Okay, level. After you got the level, how many level? Okay, for example, 8 level start from 0.27. If 2 power of 2 equals to 4 level, you start from 0 to 3. Okay, something like that. Okay. Actually easy. Last time all students managed to answer. This is a favorite question that student will score because they already know. Okay, so don't worry. Just take note what's write down here. Okay. Okay. So clear. Now, some of you will say, sir, why? Voltage range negative 6 to negative 4.5. Why we put range? Okay, the problem come here. Okay, that's why when do analog last time I said not very stable, difficult to detect error because the voltage range different. Okay, now so tell you something. This is the magic thing. Okay, let's say now after you got this table, then you relate it with the sampling interval. Okay, remember your sampling interval every 2 microsecond. Okay, all of you already actually I give you this copy in WhatsApp. Please print it. When you print, then easy. Okay, easy to understand. Okay, now the problem occurs here. Okay, remember last time I said, okay, right now you got every 2 seconds. Okay, why? You take sampling time 1 over f as you got 2 microsecond. In this case, they limit you to do T1, T2, T3, T4 only. Okay, now we go to T1 every 2 microsecond. Okay, 2 microsecond. Remember this why we need to build the quantization table, because we want to assign the level of the analog signal. Okay, so every 2 microsecond. Okay, 2 microsecond. Okay, now I zoom 2 microsecond. Okay, read the value at 2 microsecond. What is the value you get? Okay, what the value you got? Okay, give me the value there. What's the value? What's the value you got? Is it 2.6? Okay, some of you said, sir, is it 2.6 millivolt? Correct or not? You will tell, sir, 2.6 millivolt. Some of you said, sir, no lah, 2.7. Correct or not? Correct or not? Turn on your microphone. Don't say, yes, sir, don't hurt. Sir, don't hear you. Okay?
2.6.
Correct or not?
Yeah.
Kan? Some of you will say 2.7. Betul tak? Correct or not? Kan? Some of you, sir, 2. You tak reti baca lagi, cakap 2. Sir, 2.7. Sometimes ada student cakap 2.65. Correct or not? Tengah student cakap 2.65. Okay. To solve this thing, no problem. Apa yang value yang you nampak, you convince, no problem. You said 2.6, 2.7, right? Don't worry. Okay, you take this value. Okay, 2.6, 2.7. You must build the new table. Okay, the new table, this is the sampling table. Okay, this is what we call sampling table. Sampling table. Okay, don't worry. You last time you said, oh sir, I said 2.6, 2.7. You argue. No problem. This is the best thing of digital analog to digital converter. No problem, because we already set the value 2.6, 2.7. Quantized value fixed at 2.25. Okay. Sampling time 2, 4, 6, 8. Because given, if not given, you must sample every 2 microsecond. Okay. Because of what? How to get this thing? 1 divided by T. 1 divided by F S. TS. This one TS, 1 over F S. Okay. Okay. Now, 2.6 and 2.7. Okay, this is sampling table. You see 2.6 and 2.7. Okay, you want to assign the voltage. Okay, what is the quantized voltage? Okay, you see 2.6, 2.7. Okay, see from the voltage range. Where's the location 2.6 and 2.7 millivolt? See from the voltage range. Show me which level. Which level? Tessa? 2.6 and 2.7. Which one? Voltage range. Which one? Is it level 6? Is it level 5?
Level 5.
dekat mana?
Level 5.
Level 5. So, level 5. So you know this one dekat level 5. Level 5. So you take the quantized voltage. Okay. Quantized voltage at 2.25. At level 5 is 2.25. Okay. 2.25. You put here 2.25. Okay. Now, binary code. Okay, that's why I'm telling something. Why we need to build the level, because at 2 microsecond kan voltage berubah. Voltage berubah, rupa-rupanya binary code dia pun berubah lah, because quantized value dulu 2.25. We already know the 2.25. Binary code is, apa binary code dia? Level 5, apa binary code dia?
101.
So you take 101. Clear? Okay, now we go to at the second sampling, 4 microsecond. Okay, 4 microsecond. Tengok signal dekat mana, positive or negative. Okay, this one on the negative part, right? Okay, you turun bawah. Okay, what is the value here? Sezoom. Sezoom dekat 4 microsecond. Okay, dekat sini. You pun bergaduh-gaduh lah. Okay, you pun bergaduh. What's the value here? Sudah besar kan? Berapa value tu?
Negative
Okay.
4.6.
Negative 4.6 millivolt. Ada student nak marah cakap no sir, you rabun. Saya betul. 4.7 millivolt you said. No problem. Okay. No problem. Okay, just see, jangan salah lah. Okay, selagi 4.6, 4.7 in the range, no problem. Okay. Jadi you ambil negative 4.6, negative 4.7. You take that the value, you put dekat sini. Okay, you put here. Okay, 4.6. 4.7 pun tak ada masalah. Okay, that's why I said, please, you kena print, baru you nampak. Okay, no problem. Okay, tengok range 4.6 and 4.7 kat mana. Okay, kat mana range dia? Negative, right? Kat mana range dia? Where's the range? Which level? Berapa ni tadi ni range yang ni second punya interval, you kata 4.6, right? 4.6 berapa, dekat mana dia punya ni? Dekat mana dia punya voltage range? 4.6, negative 4.6 kat mana?
Level 7.
Kau tanya, negatif? Negatif lah. Kan negatif. Ni kan kat bawah. Ni tengok ni. Nampak ni kat bawah. Ni. 0, kan? Ni berapa kan? Negatif 4. Pandainya. Very good. Ni saya suka ni. Okay. So, dia kan negatif 4.6 dekat sini lah. Negatif 4.6. Dah takut dah. Okay. 4.6. Ingat all this value actually millivolt. Tapi saya dah represent dekat table. Saya ubah kat table ni. Millivolt. Clear? So dah put in the table kat atas tu, sebab tu nampak zero ni. Okay, now you dapat zero, right? Dekat zero, ni level zero. Sebab tu you dapat dekat level zero. Contrast value berapa? At level zero, negative 5.25. You bawa sini 5.25. And then dia punya okay, kenapa? Why we need this thing? Because after this kita akan use your binary code. Kita akan buka line coding. Itu yang you nampak. Kita buat line coding unipolar, bipolar, okay, polar. Itu yang kita guna. Kita akan dapatkan binary code baru boleh masuk dekat Manchester ke apa. Clear? Okay. Now the next one kita ambil 6. Sepatutnya student saya tak ada problem kot. Okay. 6. Okay, dekat 6 you tengok dia dekat positive cycle or negative cycle. 6 ya. Okay, tarik turun. Tengok ni dekat sini. Okay. Berapa nilai dia? Tu. Saya tak balik, saya berbual sini lah. Sekejap, sebut tick ni merah. Berapa nilai dia? What's the value?
3.8.
Some of you will say negative 3.8, right? Some of you will say 3.8 millivolt. Some of you will say 3.7. Correct or not? Some of you will say this value. Correct or not? Correct or not?
Correct, sir.
Some of you said so some of you said 3.8 millivolt, some of you said 3.7. Remember what is the function of PCM? Convert analog signal to digital. That's why if you scared, so what I'm doing? Oh, now I understand. We want to assign the voltage and also we want to convert from analog to digital. That's all. Okay. Now you take 3.8, 3.7, you put here. Okay. On sampling table 3.5, 3.6, 3.7, no problem. Okay, negative. Okay, 3.5, 3.7, negative, negative 3.5, negative 3.6. Where's the location? In voltage range. Where's the location in voltage range? Okay, negative 3.5. Negative 3.5. So where's the location in voltage range? Negative 3.5. Which level? Tell sir.
Level 1.
3.5 tu. Level?
Level 1.
Level 1 ni. Very good. Kita kan tak reti kalau saya tanya nak pun kat mana level kalau 3.5 dekat range mana? Macam budak tadika je saya tanya you ni, okey. Negatif 3.5 berada dekat voltage range yang mana? So if you see negatif 3.5 berada dekat level 1, betul ke tak?
Betul.
Betul.
Level 1, correct or not? So level 1, ambil nilai level 1, level 1, 3.71, okay? Then number 8 you buat sendiri lah semalas tu, sama je. Okay, takkan tengok graf tak tahu. Okay, now after you finish this thing, remember, okay, kita encode the binary PCM code. Ini yang saya bagi tahu last time during last class, kita bagi tahu you boleh after you got the signal, you akan ikut macam for example Manchester encoding, Manchester coding technique we use in local area network. Okay, so now last time nampak tak ada bit rate? Bit rate 20,000 bit per second. Okay, now ada satu lagi. Nampak tak? Ada plus minus 3 volt. Okay, sketch the result. Sketch the result. Tak ada apa. Maksudnya you nak lukis saja Manchester encoding macam mana. Okay, Manchester encoding. Tak ada apa. Okay, first before you start, okay, you kena tahu berapa second interval dia. Okay, you kena tahu kalau guna Manchester, tak kisahlah kalau line coding, you must know line coding. Okay, line coding also got, you kena cari dia punya sampling time dia juga. Okay, sampling time you must know. Okay, now kalau ini dah digital tau, ini dah 010101. Okay, you nampak tak ini signal ni dah ambil daripada mana? Okay, this signal ambil from here. But 101000001 110. Betul ke tak? Okay, you ambil value tu, dia masuk. Okay, you kena tahu. Sama, kita kena tahu sampling time dia. Okay, sampling time bagi, dalam kes ni dia bagi bit rate. Ingat ya, analog pun ada sampling time, digital pun also ada juga dia punya sampling time. Sebab tu nama dia bit rate. Okay. Okay, so dia bagi dalam soalan, in question we give you, okay, 20,000 bit per second. Okay, BPS also same. Okay, maximum amplitude plus minus, because Manchester encoding we got positive and negative. Okay, so very easy. Okay, 1 divided by 20,000 bit per second. Okay, you got the sampling time is 50 microsecond. So ni lah you boleh set up ni, berapa lebar dia. This one drawing okay, you just draw, insert the value 50 campur 50, you add up every this time ni, waktu ni you campur. Okay, sini bukan time second, ni sesilap ni. Okay, this one is microsecond, sorry. Okay, microsecond. Okay, now macam mana nak tahu tinggi? Okay, tinggi, remember kalau Manchester encoding dia ada positif, dia ada negatif. Okay, nanti you check balik macam mana selukis ni. Okay, sini ni kena tulis positif 3 volt, negatif 3 volt. Okay, happy? Okay, faham? Okay, bila dapat ini nanti tengok baliklah line coding ni, nota yang saya cakap hari tu. Okay, now ini question number 2. Okay, question number 2 ni, it will come on your quiz, your next quiz. Okay, next quiz something like this. Okay, draw the line codes for 1010 for example. So change lah here. So can change 111001, no problem. Okay, something like that. For example, okay, you draw similar like this. Okay, now so want to stop this class. Okay, so recap back before we stop. 3 o'clock segak meeting. Okay, so recap again. First of all, you must know the Mmax, the Mmin, okay, and then the 3 bit why? Because we want to do 2 power of n. Okay, we know the level, and then you must know the frequency, whether is it information signal or the sampling. Okay, because of what? You need once you got frequency sampling, you can find time sampling. This one is actually Fm. Okay, remember. Okay, now construct the quantization table. Remember, when you want to set up the quantization table, you must know the first one is the L, number of level. Okay, the second one you find the interval. Okay, the quantization interval, and then the starting voltage. Okay, on the quantization interval, what is the starting voltage? Okay, this is starting voltage. 1.5 millivolt is something like 1.5 millivolt is delta V. The difference between interval, between level. Okay, now, so want to tell us something. Okay, after you got that thing, build the table. You must have this thing. Okay, level. Okay, start with the level number 1, 0 to 7, because of what? 2 power of n. 2 power of 3, you got 8 level. Start from 0, since we are dealing with digital, 0 to 7. After you got this thing, build the binary code. 0 level 7 equals to 111. Okay, assign, change from decimal to binary. Once you got that thing, start with the quantized value. Quantized value states take the V out. Okay, V out first, V0. Okay, M min plus delta V over 2. Okay, this is the first value. The second value very simple, negative 5.25 plus delta V, you got the value of V1. How about V2? V2 negative 3.75 plus delta V. Okay, so continue till you got this value. Okay, now how about the voltage range? Voltage range, remember we got the 2 value, so you use delta V over 2. Okay, where to get here? V0 equals to M min plus delta V over 2. Okay, because we got the 2 value, so you take the quantized value. Okay, how to set up the voltage range? You take the quantized value, you plus minus with delta V. Remember this thing only. If you don't understand, just write down this thing first. How to set up the first value. Okay, negative 5.25 milli plus delta V over 2. Okay, plus minus. Okay, remember plus minus I kept again. Okay, so you apply this value, no problem. The second value, okay, for voltage range, negative 3.75 quantized value plus minus delta V over 2. Okay, so clear? Once, okay, after you complete the quantized value, you must know sampling. We create the sampling table. Sampling table for what? So that we can obtain the value of binary code. If not, we cannot. Okay, so you refer back your after that you refer back on your analog signal, start to quantize. I start to sampling first. Okay, once you get this analog signal, you must do sampling. Okay, sometimes when you calculate, you got 1 microsecond. Sometimes you get 2 microsecond, depending of now frequency sampling you got. In this question, after you find the TS equals to 2 microsecond. That's why you sampling for t equals to 2 microsecond, 4 microsecond. If your sampling time is 1 microsecond, it's different. You start with 1 microsecond to obtain the value of the analog signal. Okay. Once you get the analog signals, it's not accurate. When you see the graph, it's not accurate. That's why we must build the quantization table so that we can get, let's say, for the 2 microsecond, you got 2.7 and 2.6, no argument. Okay, take it. And then we can something like give the rough value. Okay, the rough value from here. Okay, from the sampling time, remember, sampling time used to obtain the binary code. So sampling time, you take back the sample voltage from the analog graph and then see back, okay, sample voltage from the analog graph, okay, seni, okay, sampling time from frequency sampling, okay, so make summary, okay, sampling time, okay, Fs, sampling time, from Fs you can get Ts, sampling time, okay, then sample voltage you obtain from the graph, analog graph, quantized value you obtain from quantized and binary you obtain from quantized table. Okay, okay, so clear how to get it? Okay, clear? Okay, after that, okay, so telling something, take, okay, this question, something like after that, we do put in line coding. Okay, this one Manchester, no problem. Sometimes we say line coding, we say, okay, put this value in unipolar, for example, or this signal, can be this signal, no problem. Unipolar now return 0. Okay, polar now return 0, now return 0 inverted, AMI according, no problem. Okay, we can change the question. Okay, so clear, student, how to draw? So want to stop? Okay, so need to go to the meeting. Okay, so anything you want to know? Understand? Oh my God. Okay, so need to stop because I got the next meeting. Okay, thank you class. Okay, so understand Okay, bye. So we'll give this thing later on. Okay. Thank you class.
Thank you,
Thank you.
sir.
Thank you.
Thank
Okay,
you,
bye.